In this learning objective, we're going to talk about coterminal and reference angles, which are just a way to talk about other angles in our unit circle. All right, so in our previous learning objective, we learned about how to find the sine and cosine values for angles that appear in that unit circle. But in this one, we're going to look about more angles in the unit circle. All right, so earlier in the unit, we were talking about how to find the quadrant of an angle, and we talked about angles that are bigger than 2 pi or angles that are negative. And what we saw was that an angle that's bigger than 2 pi just means you've rotated around the circle at least once, because that's 2 pi, and then maybe you did a little bit extra. So maybe this is your angle that you're talking about. But this angle looks the exact same as if I had just rotated up to there and gotten a Thackeray angle. So these two angles, the bigger angle and the smaller angle, share a terminal side. They both have that same line going off to the top right. And as they share a terminal side, they're called co-terminal angles. All right, co just means the same, and terminal. Right? They're sharing the terminal side. All right, so if we want to find the smallest angle coterminal to an angle, we just know that we can have to, so if we think about that picture before, that's one angle, and that's another angle. What I can do is kind of get rid of the extra revolution. So what I'm going to do is try to get rid of this extra revolution, and an extra revolution is 2 pi, because I've done a full circle. So what I can do is just take this angle, and I can subtract 2 pi from it. And that's going to put me back in the same place with the same coterminal angle. So that's going to be 13 pi over 6. To make 2 pi a common denominator and multiply the top and bottom by 6, that's going to be 12 pi over 6. And 13 minus 12 is 1, so it's pi over 6. So 13 pi over 6 and pi over 6 are coterminal, which basically just means they look the exact same when you draw them. 11 pi over 3, we're going to do the same thing, subtract 2 pi, which in this case, I need to multiply the top and bottom of 2 pi by 3. It's going to give me 6 pi over 3, which is, oops, there should be a minus sign there. That's going to give me 5 pi over 3. So 11 pi over 3 is the same as 5 pi over 3. And you can see these angles are angles from our unit circle diagram that we have to have memorized. All right, a couple other ones. All right, 16 pi over 3, we're going to do the same thing, subtract 2 pi. And the last example, we saw that 2 pi is the same as 6 pi over 3. Gives me 10 pi over 3. We're going to find the smallest positive angle. Smallest means that our angle is smaller than 2 pi, because that's one full revolution. 10 divided by 3 is 3.33. All right, so 10 divided by 3 is still a number that's bigger than 2 pi. So I'm going to do this again. So I'm going to do 10 pi over 3 now and subtract another 2 pi. All right, so the actual final answer for this one is 4 pi over 3. So you're going to keep subtracting until you get a number where the fraction part is smaller than 2, because that'd be smaller than 2 pi. You basically just can keep going until you get a negative and just do one less than that. But basically figuring out when is your angle less than 2 pi. The other thing is we could have a negative angle. And negative angles, if you keep subtracting 2 pi, we're going to get more negative angles. So instead we add 2 pi. So we're going to go backwards towards a positive angle. In this case, we need to multiply the top and bottom by 4. So that's going to give us 8 pi over 4. This is negative 3 pi over 4. Again, this is not enough because I still have another negative angle. I want to find the smallest positive angle, so I add another 2 pi to it. And I get 5 pi over 4. And 5 pi over 4 is positive. It's smaller than 2 pi. It's one of those angles on the unit circle, so this is the thing we're looking for. We're looking at coterminal angles. Right, the smallest one that would be on that unit circle diagram that we had to memorize for 2 learning objectives ago. All right, so here's one for you to try on your own. All right, 19 pi over 6, find its smallest positive coterminal angle. All right, the answer that you get is 7 pi over 6, so I'm subtracting 2 pi. Again, it's always 2 pi because that's a full revolution in radians. So I'm subtracting 2 pi, which is 12 pi over 6, and I get 7 pi over 6. And just one small note I wrote down here that, let's say you didn't know if you were done or not when you got to 7 pi over 6. If you try to subtract 2 pi again, you would get a negative angle, and that's how you know you've gone too far. So 7 pi over 6 is where you want to stop, because if you go any farther, you end up with a negative angle. All right, so the next thing we'll talk about is quadrants. Just kind of a recall of something we did earlier. All right, quadrants is where the terminal side of your axis lands, and we have quadrant 1, and we rotate counterclockwise to get the other 4. All right, so what quadrant does 13 pi over 4 terminate? All right, you can go back to our second learning objective of this unit and do it that way, or you could do it using coterminal angles. So I could take 13 pi over 4, subtract 2 pi from it, because the coterminal angle is going to be in the same quadrant, and I get 5 pi over 4. So 13 pi over 4 is the same as 5 pi over 4. If you think about our unit circle, this is the bottom plus 1 that's in quadrant 3. I have about 23 pi over 6. Again, I'm just going to do the same thing. Find the smaller angle that I know better. Let's see, 23 minus 12 is 11 pi over 6. 11 pi over 6 is the bottom times 2 minus 1. That means it's in quadrant 4. All right, just again, thinking about our references in the unit circle, that's in quadrant 4. And the last thing is this idea of a reference angle. So for each quadrant, there's a slightly different reference angle. So if I think about quadrant 1, 2, 3, and 4, the reference angle is always the smallest angle between the terminal side and the x-axis. So for quadrant 1, this would be your reference angle. Quadrant 2, it'd be this. And you notice your reference angle is not necessarily in standard position, but it's just between your terminal side and your reference angle. In quadrant 4, it would be that angle. Or sorry, quadrant 3. Quadrant 4, it would be this angle. It's just a small angle between the terminal side and your x-axis. This is one way that people learn how to find their sine and cosine values. So reference angles are talked about a lot when you're learning trigonometry. All right, so finding a reference angle is one of the times that radians is actually much simpler than degrees. Finding a reference angle in degrees will be covered in the bonus objectives, but for radians, basically, because we have these fractions with radians, the reference angle is basically going to be always related to whatever the denominator is. So pretty simple for radians. We're going to find the reference angle for 25 pi over 4. I first to check to make sure I can't simplify this at all. So 25 pi over 4 is the simplest I can make that expression. So my reference angle is pi over 4. Right, not very difficult in radians. 19 pi over 6, first thing to check, make sure you can't simplify it anymore because you want to figure out it's the smallest way you can write your thing. 19 pi over 6 can't be simplified, so my reference angle is pi over 6. Right, so here's one for you to try on your own. What is the reference angle for negative 7 pi over 4? Right, and hopefully you recognize that it's just pi over 4. So reference angles aren't super useful in radians, but they are pretty useful in degrees. I bet it's something that comes up a lot in trigonometry. All right, so for this learning objective, you're going to do a skill check. The skill check is going to give you 2 angles, and for each, you must identify the smallest coterminal angle, so the first set of examples we did, identify what quadrant it lies in, so the second set of examples we did, and then find the reference angle, so the last set of examples we did. So just there's 3 different things. Being able to identify all of those for any angles is an important aspect of trigonometry.